Hi everyone, welcome to lesson 3. So we will talk about the 3D vector today. But before we get started, here are some reading quizzes to get you refresh your memory a little bit. So my first question is for the vector algebra. So because we are going to use it very often in this class. So it's based on like what coordinate system. So it should be a very quick answer. So it should be the right-handed coordinate system, so which will be used for this class very often. So the answer will be D for the first quiz. And the second, what's a symbol alpha, beta, and sigma designate in what of the 3D Cartesian vector? Okay, so here's a question. So it shouldn't be a hard question. So the answer should be B. So the alpha, beta, and sigma and gamma represents the coordinate direction angles. Okay, so well, let's get started for the 3D vector. So here is an example. So for example, we have F1 and F2. The true force vector is working on the skew I, which is as shown in this figure. So we're given you F1, F2, and its angle to each axis, and also F1 and F2's magnitude respectively. So you are required to find what's the magnitude of the coordinate direction angles of the resultant force. Okay, so what should we do? So we are given two forces. Those forces, they are working in the 3D vector. So we have F1, F2. We're given the F1's angle to Z axis is 35, and also we're given F2's its angle to X is 120, its angle to Y is 45, its angle to Z is 60, and also we know F1 and F2 its magnitude is 250 and 400 Newton respectively. So how should we solve this question? So here is 3 steps. Okay, so first you need to use the geometry and the trigonometry, resolve the F1 and F2 in the Cartesian vector form. And then you need to add the F1 and F2 to get the FR. So because this question requires us to find what's the magnitude and the coordinate direction angles of the resultant force. So that's why we need to add F1 and F2. And then we can determine the magnitude and also the angles of beta and gamma. Okay. With this in mind, let's get started. So how to resolve the first F1? So first let's resolve the F1 to F1z, which is F1's component on the z direction, which will be 250 times by the sine 35 degree. And should this be positive or negative? So it should be negative because F1, its component on z, is opposite to the z-axis, so it should be negative. So use a calculator to solve what's the answer of the 250 times by sine 35. So here will be the answer of the F1z. And we have another vector, which is F prime. So its direction is showing in the figure. So F prime is a combination of some vector from x and y vector. So we need to solve it. So first, F prime is 250 times by the cosine 35. So here is a F prime's magnitude. And then F prime can be further resolved to F1x and F1y. So if we want to resolve it into the F1x, it will be F prime times by sine 25, because 25 is the angle between the F prime and its x to the xy. So if we times it by sine 25, we got its component on the F1x. And also its component on the F1y, it will be F prime times by the cosine 25. So use a calculator, we can get f1y, the magnitude is 185.6. So after we know the f1's components on f1z, f1x, and f1y, we can write f1 as 86.6 times by I plus 185.6 times by G minus 143 times 0.4 times K. So please pay attention of the negative sign here. So that's F1. So what about F2? So F2 should be a little bit more easier because its angle to each axis is already given. So F2 should be 400 times by cosine 120, which is F2's angle to the x-axis. And then times by 400 times by cosine 45, which is 40 because 45 is angle between F2 to y-axis. And then times by 400 times by cosine 60, which because 60 is the angle between the F2 vector and to the z-axis. So we can express the F2 as 400 times by cosine 120 I plus cosine 45 G and plus cosine 60K Newton. So use your calculator, you can get the F2 will be minus 200 I plus 282.8 G plus 200K. Okay, so far we already solved the F1 and F2. So here's the answer of the F1 we already solved, and also here's the answer of the F2. And the question requires us to find what's the resultant force, what's the addition vector of F1 and F2. So because we already know x, y, z component of F1 vector and F2 vector respectively, so the FR, the F resultant, will be as easy as we plus the x component of F1 and x component of F2, which is 86.6 plus negative 200, okay, become negative 113.4. And similar for G, so this will become this plus so in this way we got the F resultant. So and then we need to find what's the magnitude and direction angles for the vector. So the F resultant in magnitude will be the square root of the x square root plus y square root plus z square. Okay, sorry, it should be square root of the x square plus y square plus z square. It will be this square plus y square plus z square and under the square root. So use a calculator, you can find the final answer is 485 Newton. And what's the angle to each axis? So the alpha means the FR vector's angle to the x. It will be the reverse of the cosine of the FRX over FR. So just here's FRX over FR. You can solve the alpha will be 104 angles. So similar process for the beta and gamma. You will find the beta will be 15.1, gamma will be 18.3. Okay, so here's the example for today. And also two more quizzes. Okay, so which is not true about the unit vector, like the UA. So it's definitely a dimensionless, its magnitude is 1, and also it's always pointing in the direction of the vector A, but however it's not always points in the direction of the positive x-axis. Okay, so the answer should be C. And quiz 2, okay, we have vector f and we have a vector g. What's the f vector plus g vector? It should be 10 plus 20 I times plus 10 plus 20 g and then plus 10 plus 20 k. The answer should be 30 g plus 30i plus 30g plus 30k. The answer should be D. Okay. So example 2, we have a force Fc, okay, which is along the cable AC. So you are required to find what's the force of the FAC, okay, in a Cartesian vector form. So first, we can find the position vector RAC and its unit vector UAC. And then you can obtain the force vector as FAC equals to the magnitude of the FC times by the unit vector AC. So the problem becomes, how could we find the unit vector, okay, UAC? So as shown in this figure, when relating the A to C, we will have to go 2 meters in the X direction, 3 meters in the Y direction, and minus 6 meters in the Z direction. So which means the RAC becomes 2 times by G plus 3 times by 2 times by I plus 3 times by G, and the minus 6 times by K, because we need to go minus 6 meters in the Z direction. And also there's another way to find the RAC, which is by subtracting the coordinate of the A from the coordinate of the C. Okay. The A is 0, 0, 6. The C is its coordinate is, it should be 2, 3, and 0. And RAC will be 2 minus 0, 3 minus 0, and 0 minus 6. It becomes 3, 2, and minus 6. Okay, you can get the same answer as well. So we know RAC is 2I plus 3G minus 6K. Right now it's not a unit vector so far. So how to get a unit vector? We need to find its magnitude first. So the magnitude of RAC becomes square root of x squared plus y squared plus z squared. It becomes this equation, and the final answer is 7 meters. And the unit vector will become vector RAC over RAC's magnitude, and the FAC, as we mentioned before, will be the magnitude of the FC times by the unit vector UAC, which become 420 times by the UAC, which is RAC over RAC's magnitude. So if the final answer will be 412 times by 2I plus 3G minus 6K divided by 7, which is its magnitude. So the final answer is 120I plus 180G minus 360K Newton. Okay, you can pause this video and check your answer before you move on. So let's recap this key concept. First quiz, what's a position? How should we calculate the position vector of the RPQ? So well, if we go back to this example, how we calculate RAC? The RAC is calculated by subtracting coordinate of A from coordinate of C. So in other words, if you want to calculate RPQ, it should be coordinate of Q minus coordinate P. Okay, second question. The force of the magnitude F, okay, directed along the unit vector U is given by F. So if we go back to this question, the FAC equals to magnitude F of the FC times by the unit vector of FAC. It will become A F times by its magnitude times by the unit vector. Okay, what about this question? P and Q are 2 points, okay, in a 3D space. How the position RPQ and RQP related? So as we talked about before in this question, RPQ is the coordinate of the Q minus coordinate of P, and RQP will be the coordinate of P minus coordinate Q. So which means the RPQ will be the negative of the QP always. Okay, so the answer should be B. Okay, the last question. We have 2 points in the 3D space have coordinate of P and Q. The position vector RQP is given by. So if we go back, the coordinate of the RQPQ is coordinate of Q minus P. If we go back here, the RQP will be coordinate of P minus Q, which means it will be 1 minus 4, 2 minus 5, and 6. And 3 minus 6 to become minus 3, minus 3, minus 3. So answer will be B. So well, that's pretty much for today's lecture.